Hi students, I am going to start chapter 6. Already we completed for exercise 5.5 and chapter 5 is fully completed. The fifth chapter is completed. Now I am going to start applications of vector algebra. The sixth chapter is applications of vector algebra. Already we have learned in 11th standard basic of vector algebra. The basic of vector algebra is already learned in 11th standard. Okay. So now the remind the value of vector algebra. So now applications of vector algebra. So the important points of remind now. The geometric introduction to vectors. Length of vector. Let OA vector equal to A1 I cap plus A2 J cap plus A3 K cap. OA is a position vector. The position vector of OA now is A vector. A vector equal to OA vector, and OB vector is a position vector. The OB vector equal to B1 I cap plus B2 J cap plus B3 K cap equal to B vector. Okay. So now AB vector equal to OB vector minus OA vector. AB vector equal to OB vector minus OA vector. Okay. So now OB vector in this position vector, to apply the value equal to B1 I cap plus B2 J cap plus B3 K cap minus of OA vector equal to A1 I cap plus A2 J cap plus A3 K cap. Okay. So now take I is common value, take outside B1 minus A1, B1 minus A1 I cap plus B2 J cap and minus of A2 J cap is J is common value, so take outside B2 minus A2 J cap plus B3 K cap minus A3 K cap. K cap is common value, so take outside B3 minus A3 K cap. Now the determinant of AB vector. The determinant of AB vector, it means the square root value of I coefficient is a square value and J coefficient is square value and K coefficient of square value. So now the AB, determinant of AB whole vector equal to root of B1 minus A1 whole square plus B2 minus A2 whole square plus B3 minus A3 whole square. Now next one, determinant of A vector. Determinant of A vector equal to A vector is a OA vector is a position vector. So A vector equal to A1 I cap plus A2 J cap plus A3 K cap. So now the determinant of A equal to I coefficient of A1, so A1 square plus J coefficient of A2 square plus K coefficient of A3, so A3 square. Then the modulus of B vector equal to root of I coefficient of B1 square plus J coefficient of B2 square plus K coefficient of B3 whole square. The determinant of the values. Okay. So now the next page. Note the addition and scalar multiplication. The addition and scalar multiplication on vectors in three-dimensional space are defined by the three-dimensional space are defined by A vector plus B vector. A vector plus B vector equal to A vector equal to A1I plus A2J plus A3K and B vector equal to B1I plus B2J plus B3K. So now A1 and B1 is a I cap is common value, so take outside A1 plus B1 into I cap plus A2 plus B2 in J cap plus A3 plus B3 into K cap. Okay, so now the alpha means is a scalar value. Scalar value in multiple of A vector equal to everyone in multiply now the alpha. So now alpha into A1 I cap plus alpha into A2 J cap plus alpha into A3 K cap, where A is equal to A1 I cap plus A2 J cap plus A3 K cap, and B is equal to B1I cap plus B2 J cap plus B3 K cap. Okay, that's all. We will meet the next class.